Hey, this is Mr. Aiden. This is section 2.7, finding domains, their limitations, sketching graphs of rational functions. We're finishing off chapter 2, which chapter 2 is polynomial rational functions, and we are finishing it off today. So let's get to this. There are limitations to domains. We saw this in the last video that when we have vertical asymptotes, when we have holes, this is when the function is not continuous, and these are where our domain is split up from being all real numbers. So we found one of those last time was, what's the limitation to the domain? That's when the denominator is equal to 0, when we're undefined. We can't be a 0 for the denominator, so that is a limitation to the domain, or the x values, or the independent variable. The square roots are also limitations to domains, because square roots can't be negative numbers. That becomes complex. And so you can be 0 for a square root. You can have the square root of 0. The square root of 0 is 0. You can have a square root of a positive number, but you can't be a square root of a negative number. That's a limitation to its domain. And also logs, natural logarithms. You cannot be zeros. You cannot be negative numbers for logarithms. And this is a limitation to the domains. So you're looking out for, when you're trying to find the domain, there's 3 different limitations. There's denominators, square roots, and logs. So ask yourself all 3. Do I have any of those things? So let's take a look at some examples. We're going to find a domain. So here we have our function x plus 1. Okay, and this is what my graph of x plus 1 looks like. Let's just take a look. Do I have a denominator? No, I don't have a denominator, do I? The denominator is 1. Okay, we can't set that equal to 0. Do I have any square roots? No, I don't have any radicals. Do I have any logarithms? No, which means the domain is all real numbers. How do we write all real numbers? Is we can go from negative infinity all the way to infinity. That is my domain of this function, because this function does not have any of the 3 limitations. Let's go to example number 2. We have an x squared plus 2x minus 1. Obviously, there is, you can take a look, this is a parabola, this is a quadratic. Do I have any denominator? No. Do I have any square roots? No. Do I have any logarithms? No, which means what is my domain for this function is all real numbers. We can have an x value. You can plug in x values in here all the way from negative infinity to positive infinity. You can plug every single value of x and you will get a y value here. And so the domain is all real numbers, negative infinity to positive infinity. Let's go to example number 3. Example number 3, we're going to try to find a domain. Now, what do we have here at the bottom? We have a denominator. We have a denominator, so let's work out this denominator. Let's try to factor it out. So we have x and x, that's x squared. What's the factors of negative 2 is positive 2, negative 1, that adds up to positive 1x. And do you see how I have one value that's canceling out? What happens if I have a value that cancels out? That means there is a hole. There is a hole at x is equal to positive 1, isn't there? So right here, there is a hole. And what do I have right here at negative 2? We have a vertical asymptote, don't we? Because that is where my denominator equals 0. So those are limitations to our domain. Limitations to our domain. So what would our domain be? What would our possible x values that we can plug in? Well, we can go from negative infinity all the way to negative 2, but we can't be negative 2, so that's why it's a parenthesis right here. We can't be negative 2. That's a limitation. If you put negative 2 in this function, you get an undefined value on your calculator. Okay? And we're going to put union, and then we're going to go from negative 2 all the way to positive 1. Why positive 1? Because there's a hole here. That's why we're going to put a parenthesis. We can't be at positive 1. If you put a positive 1 in this function, you're going to get an undefined value on your calculator. And then we can go from positive 1 all the way to infinity. So all real numbers except for x is equal to negative 2, x is equal to positive 1, and that's what this shows, is that is the domain of this function. The limitation is because it has a denominator. Let's take a look at this one. This one, do we have a limitation? Do we have a denominator? We don't have a denominator, but we do have a radical. We do have a radical. Now, I want you to see, something my students forget about is the square root of 0 is 0. So you can be 0. We can be x is equal to 1. X is equal to 1 does work. It does work. And anything greater than 1, anything bigger than 1 works as well. Anything less than 1 does not work. And take a look at this graph. This graph, you can see we have a point right here at 1. At 1, we're equal to 0. And at every point after this, it works, which means what would be your domain? What would be your domain? You cannot be anything less than 1, but you can be 1, so we're going to put that in a bracket. We can be 1, and we can go all the way to infinity as well. Okay, so the reason we don't use a parentheses here, we use a bracket, is we can be 1. 1 minus 1 is 0. The square root of 0 is 0. That is an allowable number, but anything less than that. Now, most people in past math courses, you would write something like this. X can be greater than or equal to 1. Okay? We will write it in this form, which is we can be 1 and go all the way to infinity, and that is the domain. The limitation was a radical. Now take a look at this one. Do we have a denominator? No. Do we have a radical? No, but we have a logarithm, don't we? We have a natural logarithm. So logarithms cannot be 0, and they cannot be negative. And so you can see, even look at this graph, we have a vertical asymptote here at -1. We can't be -1, but we can be anything greater than -1, can't we? So we're going to put a parentheses, -1 to infinity, because to show our domain, because we don't have a bracket. We can't be -1. If you do this in your calculator and you put natural log of -1 plus 1, you're going to get undefined on your calculator. But we can go from -1 all the way to infinity, not including -1. Okay, and that is how to find the domains. So how do we sketch rational graphs of rational functions? Well, it's better than how I draw the bird picture. Okay, is you want to find your y-intercept, which means you set x is equal to 0. You want to find your x-intercept, which means you want to set your y equal to 0. You want to try to find your vertical asymptote. You want to try to find your horizontal asymptote. You're going to try to put all of these things together that we have done in order to try to find, sketch the graph, and also sketch a few additional points. So we have this one right here. We have the function is 3 over x minus 2. So let's first take a look at y-intercepts. So how do we find y-intercepts? We're going to plug 0 in. And so our y-intercept is going to be at 0 and -3/2 because we just plugged in x is equal to 0. So our y-intercept is -1.5 right here. Okay, it's a point that I know. Now let's try to find my x-intercept. So how do I find my x-intercept? Well, I'm going to set my y equals 0, which means I'm going to find out where this equals 0. Okay, and there's no way to do that because 0 is equal to 3. You can't do that. It's not going to give. There's going to be no x-intercept. Something else along with this is take a look at the horizontal asymptote. Take a look at the horizontal asymptote. Which degree is bigger, the numerator or the denominator? The denominator is bigger, which means when the denominator is bigger, y equals 0 is a horizontal asymptote. So I know I have a horizontal asymptote at y is equal to 0. That's something I know. Which means let's take a look at my vertical asymptote. How do I find my vertical asymptote? Well, I try to find out where the denominator, I set the denominator equals 0. X minus 2 equals 0, which means x is equal to 2 is a vertical asymptote. So I have a vertical asymptote right here. Okay, and then I'm going to plug in a few points. I might plug in 3. Okay, so x is equal to 3. So 3 over 3 minus 2, that's going to be, 3 is going to be equal to 3. Okay, I might plug in 5. 5 would be a great number to plug in because 3 over 5 minus 2, that's equal to 1. Okay, let's plug in, let's plug in 1. Okay, or yeah, 1. 3 over 1 minus 2, that gives us -3. So 1 is going to give me -3. Can you see how this graph is going to be? This graph is going to come this way, come straight down. It's going to come this way, and like that. And so you can see your domain is going to be, your domain will be from negative infinity all the way to 2, and then from 2 all the way to infinity right there. Okay? And that is the sketch of the graph of the rational function. Let's do another example. Let's sketch this guy's graph. So what's the first thing I want to do? I want to find my y-intercept. How do I find my y-intercept? I set the x is equal to 0. So I end up getting undefined. Undefined, which means, what do you know? That kind of goes with my vertical asymptote, doesn't it? Why does it go with my vertical asymptote? When x is equal to 0, that is where I have a vertical asymptote. So I know my vertical asymptote is going to be right here. Okay. So sometimes your y-intercept and your vertical asymptote, your x-intercept and your horizontal asymptote, they go hand in hand. Okay. So let's take a look at my x-intercept. My x-intercept is where I'm going to set my y is equal to 0, which means y is equal to 0, which is equal to 2x minus 1. So I add this over here. 1 is equal to 2x. X is equal to 1/2. So x is equal to 1/2 is where I'm going to cross over the x-axis. I also want to take a look at my horizontal asymptote. Horizontal asymptote, remember I'm looking at degrees. The degree is 1, the degree is 1. They're the same, which means I take 2 over 1. I just take the coefficients. And I have a horizontal asymptote right here at 2. What am I going to do now? I'm going to plug in some points that might help out. Okay, so I might plug in 4. 4 is a great point. Why? Because I can do this. I don't know which point to plug in. Let's plug in 4. Sure. So 4, we're going to get 8 minus 1 over 4. That's 7/4. So like over here, let's can you see what's going to happen here? We're going to be like that. Okay. Let's plug in something like -1. Let's plug in something like -1. So -1, we get -2 minus 1 over -1. So we get -3 over 1. That's 3. -1, we get 3. That's really good. We could plug in something like -4. So let's plug in -4. Who cares? So -4, that's -8 minus 1 over -4. That's -9 over -4. That's 9/4. That's going to be right around here, so you can see what's going to happen. Here's a good sketch of my graph. Okay, so you're trying to find the y-intercept, the x-intercept, vertical asymptote, horizontal asymptote, and a few extra points, and you can see what is my domain from negative infinity all the way to 0, from 0 all the way to infinity for that sketch of that rational function. Example 8, which is sketching the graph of a rational function. We're going to first take a look at the x-intercept. The x-intercept, we're going to say y is equal to 0, which means x is equal to 0. It's the same with the y-intercept. Y-intercept, x is equal to 0, y is equal to 0. So I have this point right here at 0, 0. If we take a look at my vertical asymptote, I want to factor this denominator, don't I? Okay, always try to factor denominators if you can. So we have x and x. We have -2 and +1, which means x is equal to 2 and x is equal to -1. We have some vertical asymptotes right at these guys right here. We also want to look at a horizontal asymptote. How do I look at the horizontal asymptote? I take a look at the degrees. The bottom degree is bigger, which means y is equal to 0 is a asymptote right here. Okay, and then I'm going to plug in some extra values. Okay, so I'm going to plug in some values that are going to be less than -1, maybe -2, -3, and when I plug in -2 and -3, I'm going to find out my graph is going to look like this. Okay, when I'm going to plug in values above 2, I would find out that my graph is going to look like this. And then I'm going to plug in a few values in between -1 and +2, and what I would find is this guy is going to look like that. Okay, and so you might say, Mr. Aiden, how come the the horizontal asymptote, how come we cross 0 right here? It's because of these first two values right here. So you can see, what's my domain? My domain goes from negative infinity all the way to negative 1, then from negative 1 all the way to 2, then from 2 all the way to infinity right there. And that is what my sketch of my graph would look like for example 8. We got one last example. That's example 9, the sketch of a graph of a rational function again. And what do I always want to do? I want to see if I can factor the numerator and the denominator. So the numerator is one of those x plus 3, x minus 3, because the middle number cancels out. The bottom number is, we have, what are the factors of negative 3? Is negative 3 and positive 1. What do we see right here at x is equal to 3? There's a hole, isn't there? Because they cancel out. What do we see right here? There is an asymptote at x is equal to negative 1. So we know we have x is equal to negative 1. We have an asymptote. We have x squared over x squared, which means 1 over 1. That's going to be my vertical asymptote. And now I can plug in a few values that I might know. I can also, if you can think about it, I can also find out my y-intercept by plugging in setting this equal to 3, okay? And so, setting that equal to 3, that equals 0, so we know we are up here. And so you can see how here we have our graph. If we put in a few extra values, we're going to be coming down here, okay? And then remember, at 3, there's going to be a hole, isn't there? Because of that hole right there. And then we're going to continue on. If you took a look over here, where our graph, plug in a few extra points, our graph is going to look like this when we sketch it out, which means what would be our domain of this graph? We would go from negative infinity all the way to negative 1, from negative 1 all the way to the hole at 3, and then from 3 all the way to infinity. This is where we are discontinuous at this asymptote and this hole. And you can see that is my sketch of my graph of my rational function. And that is the last thing in Chapter 2. So I hope this helped. This is finding domains, their limitations, and sketching graphs of rational functions.